Hello, in this lecture, I want to give a little introduction to design patterns. So, what we will see what are design patterns, why they are good. We will also show an aspect that is often not really treated in lecture. This is that design patterns are not a panacea. So this means that sometimes you should not use them, and give some example. So in fact, design pattern, they come from this book that is The Timeless Way of Building, that has been written by Christopher Alexander. This was an architect, a real architect, not a software architect, that tried to write patterns so that people can build their own house and cities. So he developed patterns and pattern languages, and then they tried to apply that, I guess that is in Mexico or something like that, where people could build their house. It didn't really work. So from that perspective, I think that Christopher Alexander is not really well known as an architect, but in software, and in particular in object-oriented design, it worked wonderfully. And this is what I want to show you with this little introduction. So basically, design patterns are recurrent solutions to design problems. The idea is that a design pattern will capture some similar problem that you have at the design level, and they're based on the idea that experts, in fact, often solve the same problems with the same solutions. And basically, design patterns, there are also pros and cons. Okay, if you apply this pattern, you will gain this, but you will have this disadvantage. And something that is more important from my perspective, this is that design patterns are literature. So basically, teaching design pattern is possible. This is just painful usually for the teacher. And I really encourage you to read them, because originally they were rewritten as knowledge that should be read. And I can say that because I wrote some design pattern in the past, and I saw that really when I'm teaching. So what are design patterns? So in fact, design patterns, they are elegant solutions that usually a novice could not really thought about. They should be generic, because we don't want to have something that is super specific to a super small language or something like that. This is absolutely not interesting, because it should be language agnostic. So they should be generic and independent also of a type system or reflective features or things like that. Usually they are well proven. So this means that you don't want something that is totally ad hoc and that works on only one case, but that is working most of the time. When you have this problem, you can apply this pattern. They should be simple, because most of them are simple, but the cool aspect of them is that they can be composed together to build more complex solutions. So basically, over the MOOC, we will show you some design patterns that are building bricks that you can assemble to produce nice design. What you should pay attention is that you should also be always be skeptical and take everything with a piece of salt. This means that they are stupid patterns. So in some books, you have, for example, the super, which means that maybe one guy invented that and he thought that this is a design pattern, but this is not. This is just a stupid pattern. So the important point, in fact, design patterns are names. In fact, they create a vocabulary. For example, you have hook and template, factory, composite, visitor. Those are names. And what I like is that when you get this vocabulary, you can talk at lunch or on the blackboard with your colleagues, and you will all share the same vocabulary that is at the same time abstract, because this is an abstraction, but really precise. So, for example, it happened to us that, for example, we discuss, oh yes, I use a composite, and we all know what a composite means. So again, read them, because like that you will really understand the fine-grained aspect of the pattern. In this lecture, we will give you a first good basis and discuss sometimes some advanced point, but read them. This is the message, if you didn't get it. So what the design patterns are not. So design patterns are not just one implementation. They are illustrated with one possible implementation. But what you should always consider is that the implementation is less important than the intent of the design pattern. This is what I will show you in a moment. And that you can bend the implementation to your own needs, if you understand what was the intent. The element of a design pattern. So usually a pattern has a name, that is basically your vocabulary. It has an intent that describes the goal of the design pattern. It has a problem description saying, okay, we are in this context and we would like to do that, but we don't want to use condition, or we want variation, or we want something that is modular, etc., etc. So this is really the context. And then after you have a description that is usually generic in terms of what are the elements that compose the design pattern and what are the relationship and responsibility between these elements and how do they interact. This is what is called collaboration. And then after, usually you have the consequences. So this means if you apply the pattern, what are the results and what are the trade-offs that you get. So I just want to illustrate that with the strategy design pattern. We will see it again later in the lecture, but it's interesting to look at it now. So the strategy design pattern, the intent, this is define a family of algorithms, encapsulate each of these algorithms in a separate class, and define each class with the same interface so that we can interchange them. So you see, this is the intention. We do not discuss about the implementation at this level. Now, a possible implementation, this is that you have what we call a user that define a strategy. So let's look at a possible implementation. Here you have a user class that has a field strategy. This field, in fact, will hold an instance of one of the subclass of this hierarchy. What is important to see is that here, the user class will have one operation and that this operation delegates to the operation of the strategy. And what it means that at runtime, I can put an instance. So imagine that I have an instance here. So this is strategy 1, and this one, this is strategy 2. At runtime, my instance of user may have a pointer to this guy or a pointer to this guy and change dynamically. In any case, the fact that I have the same operation will make sure that I can switch dynamically and that when I switch, I get automatically the correct operation that is invoked. So strategies, for example, are good to be able to encapsulate different behavior. So this means that I can have one here and one there. And they are based also on this idea of delegation. So this means that the user will delegate to the strategy a part of its behavior. This is one implementation. And then there is the question of, do I pass or not the user? This means that here with this, do I pass the user or not to the strategy? The boundary between the user and the strategy. Because often what you do is that at the beginning of your design, the user and the strategy code is mixed together, and then you cut it. And you separate and you said, okay, I have the user on one end and the strategy on the other end. But this means that the strategy may need to have access to the state of the user, and this is not always possible. So then you will have really what we call a design decision that would say, okay, should I pass or not? And if I pass the user to the strategy, what does it mean in terms of API of the user? So typically, if you look at a text editor, you will have a text editor with a formatter. So usually we will ask the editor, oh, we want to format some text. And the editor will say, oh, no problem, I will ask my formatter. So what is this formatter? That will be one instance of these classes. So maybe I will use the fast formatter, or maybe I will have the slow formatter, or a null formatter, a formatter that just do nothing and return the text. And then it means that what you see that the editor will just forward the message format to the formatter. And each of the strategy will implement the message format, the method format is in its own way. So this means that like that, from the editor perspective, I can say, oh, now I have a large code, so I would like to use the fast formatter, or if I have, I want really to have a beautiful code, so I will use, for example, the slow formatter. And internally, each of these classes can have its own decision. So what you see here is that in the fast formatter, the format method will just invoke this protected method. That's why we put this hash, the protected method format fast coloring. And if in the case of the slow formatter, I will have the same with format slow but precise coloring. So, and the idea, this is really based on this delegation. So this link is really super important. And what you see that the design is really simple. The user of the strategy delegate to the strategy. So let's step back. So this was an illustration of the design pattern. In fact, if you look at the books, they have different categories. And usually the categories, you have creational design patterns. So they pay attention to how do we instantiate object and configure classes. You have structural pattern. This is how do we compose class in larger structure and separate interfaces and implementation. Or you have more behavioral design pattern, which are more like algorithms, like the strategy, for example, or division of responsibility. So if we look a bit at the list, I put in bold the one that you will see in the lecture later. So the builder. So the builder, this is how can I create a complex object but in a programmatic way. Or the singleton, this is how can I get a class with only one instance. And for this lecture, you should pay attention because most people believe that they get it, but most people get it wrong. So you will see that this lecture, while the singleton is really simple, there are some challenges that are worth to really understand. From the structural point of view, the composite pattern, this is really a natural pattern that is supporting nested data structure like trees, document, and things like that. We will look at the decorator. So the decorator, this is how can we dynamically attach new behavior to an object. And we will go over the flyweight. So the flyweight, what is interesting, this is how can we share and manage a lot of objects without duplicating them and making sure that we optimize a bit the space. From the behavioral pattern, we will look at command. So command, this is a pattern that is turning an action into an object. So it reifies operation. This is what you get behind the do and redo or undo and redo. The state pattern, this means that if your domain can be really expressed as a state machine, then we can apply the state pattern. So we saw the strategy. So this means that we delegate behavior to objects that are responsible to manage a part of computation. The template methods, this is really the core of object-oriented programming. This is template method. This is also named hook and template. So this is that how can you make from a superclass, make sure that the code of your subclass that get injected and used instead of your code. And this is really the extension. This is the extension of object-oriented programming when we use inheritance. And we will go over visitor. So basically, visitor, this is, I want to have first-class operations that are expressed on a composite pattern, but in a modular way. This is one of the most complex design patterns that we will present in this MOOC. And what we will see is that it is using double dispatch. So we will do a double dispatch lecture so that you can understand double dispatch, but also how this is used in the visitor. In this MOOC, we will present also some other design pattern. One is called null object. This is how can we turn a null behavior into an object instead of having condition in the code. And type object. Type object, this is something that you get when you want to separate, for example, the kind of object from the object itself. So for example, if you want to represent a DVD and the actual DVD. So the DVD has, okay, this is this video that I want to watch from the actual physical DVD. If you have a renting, if you rent a DVD physical object, then you want to model that as a type object. So this is a bit abstract, but you will see that in the lecture, it is a lot clearer. What you should pay attention is that design patterns are not a panacea. So what is important to understand is that after this lecture, and once you have read the book also, this is important to understand why you do not want to apply a design pattern. So once I saw a company that was testimony, and they said, yes, we implemented in this application, we implemented all the design patterns from the catalog. And for me, this is a big warning. You don't want to implement all the design patterns from the catalog in your software. You just want to use the one that makes sense. So it's look okay when I say it, but I can tell you that when I was discussing with this company, I was really scared. So this means that people think like that and you should not. So what you should pay attention is that design pattern makes your software more complex. You will have more classes, you will have more indirection, you have more message. So this is important to understand when you don't want to apply them. A second alert, this is that design pattern is about intent and trade-offs. If I need this goal, and to reach this goal, I will have to pay the price somehow. And you should not confuse intent and implementation. This is what I try to show you with the strategy. You see the intention of the strategy. This is to define a family of algorithms that we can interchange. There is nothing about the implementation. You can do it via delegation, and this is the good way to do it via delegation, but the implementation is not the intention. About the MOOC. So there are several books, and the one that I like, there is the design pattern. So this is the seminal one. This is the first one by Gamma and others. This is called GOF, the Gang of Four, because they were 4 authors. And there is the one that I prefer. This is the design pattern Smalltalk companion, because it is better. Let's say it like that. Of course, I am a guy that is doing Pharo, so I'm biased. Now I want to show you what I found long time ago on Amazon. And there was this guy, Nicolas Weidmann from Zurich. He said, okay, I'm a C++ programmer. This is 9 years that I develop in C++, and I have the Golf book. I never like it. So, and he said, the Smalltalk companion is much easier to read and to understand. So when I read that, I was like, oh, wow, that's cool that is mentioning that, because I like the Smalltalk one. So, but I'm not a C++ programmer. In any case, you can read both of them. They are cool. So in fact, design patterns are reusable solutions to common problems that are based on experience from real system. That's really what is interesting. This is that the design has been validated and the pros and cons has been discussed by people, so over multiple years. So this is really interesting to understand them. There are also names of abstraction, and they create this common vocabulary so that we can go much faster to discuss design on the blackboard. And for me, this is the key aspect of it. This is the communication. How can I discuss my design with somebody else so that he can criticize it? And they often separate modularity. So this means that you will have the interface, separation, and implementation. And this design pattern, they are really the basis of most of the available frameworks and toolkits that you have nowadays. So they are really worth looking at them.